Well, hey guys, today I'll be working on a project, little issue I'm having with keeping my refrigerator in my garage running when power goes out. So let me switch my camera around here. I got a pretty elaborate setup here. My main power comes in here. I go to a terminal block up here where I split into three 200 amp breakers, and then I go to three 200 amp manual transfer switches, and then one 200 amp automatic transfer switch. I also have a place where I can tie in a gas generator, but my primary generator is this 40 kilowatt Cummins diesel here. What's happening is my house is over there. My house has two 200 amp panels, but I only switch one automatically, and that's sufficient when the power goes out. If I want to manually switch in the others, I can manually switch in this one, or if I want to manually switch in the garage, which is where everything here is mounted on, I come and throw that one. The problem is I have a refrigerator in this garage, which I also have a freezer attached to it, and I keep a lot of stuff in there. My dog heard me talking back here and assumed there was somebody back here. There she is again. So my problem is, like I said, the refrigerator. I want it to continue to run without me having to come here and manually switch in the garage. I had a problem last winter when I was out of town. Snowstorm came in, power went out, everything automatically transferred here. But I had to have a neighbor come over and transfer this so my refrigerator would continue to work. So what I'm going to do is I'm going to tap off of the feed going to my house using some parallel taps, and then go inside and make a little small sub panel with one breaker in it to feed the refrigerator. And since this is before the panel, it's actually between the panel and the incoming meter here. There's an article in National Electric Code. It deals mostly with RV receptacles and EV receptacles. You can put a distribution center or receptacle, whatever, prior to your main feed, but it can only be 10 feet, 10 wire feet, I think is the way it's specified, from the point you tap in. So mine's only going to be about 18 inches, so I'm well within that. So that's 18 inches of wire that'll be quote unquote unprotected, if you will. But it's all going to be inside that automatic transfer box, and a little short piece of conduit going to where the breaker is going to be mounted in a little distribution panel. So that's my project today. I'm going to show you the little taps I'm going to use, and then we'll go inside and look at the automatic transfer panel and show you how I'm going to tie that in. These are the little pieces I was talking about. I call them parallel taps. People just call them taps. The guy at the electrical distribution place, I had to explain to him what it was. He'd never heard of them, and another guy at the city counter there, he goes, "Oh, I know exactly what you're talking about," and went back and found them for me. But basically, they're insulated, and you put them over top. See if I can do this with one hand. You put them over top of your main conductor, which in my case is a piece of 4/0, and you can see the little teeth in there. They bite through the insulation and make your connection, and then your parallel piece goes in here, and this particular size is a 4/0. And it goes between a number, let me see what it says, a number 6 and a number 14. So I'm going to be running probably a number 6 or a number 8 stranded in here, so that's well within the range. But you put this around your cable, you put the cables in there, you lay them in there straight, you squeeze it down on there, and then you torque this nut down on it, and it gives you a torque spec. I think it's 156 inch-pounds. And that makes your connection. And like I said, it's insulated, so it'll work fine inside that panel. And that way I don't have to cut and splice my piece of 4/0, which I really didn't want to do. But this will work nicely for a little 20 amp circuit, which I'm going to run my refrigerator. And over here is the little distribution box I have. It's the smallest one I could find. It's got four breaker slots in it. I'm only going to put one breaker in it, to run the refrigerator. That's all I ever want to run on that particular circuit. I've already got the cable run for my refrigerator. I have a special socket for it, receptacle, if you will. It's down behind here. You can't see it. But there's my 1970s refrigerator from GE. It'll outlive us all. I got that when I built my first house in 1977, I believe, and it's been running ever since. So that's a refrigerator I want to keep running here in my garage. So hopefully I'll be able to get that done using these things, and I'll kind of show you the process as I go along. As I was working, the automatic transfer switch over there automatically kicked in my generator, which it does once a week, and I always come over and check it if I'm at home. I always check to be sure the voltage is right. Of course, see if the engine is right with the oil pressure and water temperature. And this particular generator comes with a manual load, and I'm going to kick in a load that'll put about 90 amps worth of load on it. As you can see, it was drawing just under 90 amps, 240 volts, 60 hertz. Everything was good. I cut the load off. The generator runs for about 15 minutes once a week, and that does a test. The load doesn't come in automatically, but when I think about it, I switch that in because just running the generator doesn't really test the load at all. So I always put the load on it and check to be sure it's putting out current. This will give me just under 200 amps, more than enough for everything I need here. A lot of people say it's overkill, but that's pretty much my middle name. So I got this generator, off of eBay. Gosh, I got my name down here in the concrete. Looks like 2007, so I've had it for a while. I bought it, it only had 13 hours on it. So it's been a good generator for me. I've done a few little things electrically to keep it going, but nothing major. I keep the oil changed and everything topped off, so it's ready to go all the time. So I've got my distribution box mounted inside here. There's an old conduit I've got to cut out, so don't pay any attention to that. But I got my conduit pulled through the back of the automatic transfer switch. I had a short nipple. Turned out it wasn't long enough, so I ended up having to use a PVC nipple, which I just glued on there. It's not as good looking, but serves the purpose, protects the wire. So I'm gonna pull the wire through. I have my number 6 wire here. Got them phased. I got a red, a black, a white, and a neutral. Since technically this is a sub panel, since it is after the first means of disconnect, I have to separate my neutral and ground, which here's my neutral bar, and I'm only going to have one ground here. So that's my separation of neutral and ground there. And my Romex will come in here, and obviously the ground will go there, the neutral will go there, and the hot will go to the single breaker I'm going to install on that. So I'm going to pull this wire through, terminate it here, then I'll cut the length the other side, and I'll use those little parallel taps, and we'll get to that in a minute. All right, guys, I'm back. My plan of using the little parallel tap connectors that I showed you the other day, they wouldn't work, because you need a straight section of cable to put those on. It can't be curved or anything, and I just didn't have enough room in the panel to do that. So I looked in there again. I'll show you in a second. I have some 2-port, I call them clear taps, but People call them taps, Patriot taps. There's about a different names. These are made by ASI. Anyway, I have some 2-port ones in there where I've got a 4-aught in and a 4-aught coming out, where when they put it in, the cable wasn't long enough. That's perfectly fine. My problem was, since I'm putting a number 6 cable in there, I didn't think I could, crunch it down in there. But I found these. Actually, a good friend of mine who's an electrical contractor found these. These actually go from 250 MCM, which is a little bigger than 4-aught. 4-aught's about 212 MCM. And that's Mills Circular Measurement, I believe it stands for. But anyway, this will go from the 4-aught, and the minimum size it'll hold is a number 6, which is fortunately what I'm going to. So I'll be able to put a number 6 in here and crunch it down, and then put the 2 4-aughts in there and crunch those down and still make a good connection. And it's got these little caps in here that cover those up. And it's got the anti-ox in there for aluminum conductors, which I do have. So anyway, that's all set up. So what I'm going to have to do is kill power to my house. My wife's not real happy about that, but I'm not going to do this hot for sure. I've got to shut off and lock out my generator. Then I got to kill power to that particular portion of my house. Then I'll measure it with an ohm meter, and then I'll start swapping these guys in and out. Hopefully I won't have power off for about a half an hour, but you know how those things go. So let me start doing that, and I'll show you what I'm up to. Well, there's a couple things I do to my generator so it won't start. One, I take it out of remote and I put it in stop. And I get that flashing light that says I'm not in remote anymore. And then the next thing I do is I shut off the main breaker coming from the generator. So the generator can't start, and if it does start, it won't give me any current. Okay, I'm here at my automatic transfer panel. Down here, this is still hot, so I'm going to be careful where I stick my hand. Down here, you see I've got the 3 2-port taps. That's a neutral, that's one phase, and that's the other phase back there. But you can see where I would have had to use those parallel taps. Excuse me. There's not much straight portions of cable that are easy to access, and then actually the ones I need to access are the ones way in the back there that go way back in the back there, and then they come down here and tie it in. So they wouldn't have worked for me. So what I'm going to do is replace these 2-port taps with the 3-port taps, and then tie in my number 6 cable that I pulled from the refrigerator. This is my manual transfer switch. It's in power company now. Generator's down here. I'm going to switch that to the off position, and that feeds, that's the power feeding in. My generator feeds from the bottom, and then I'll double check that there's no power in here, and then I'll start working on everything. And I'll show you there's no power by the time, once I shut it off. All right, I'm getting ready to kill the power here, but I want to show you, this is the incoming power from the power company. And that's 240. This is where the generator would feed, and right now that's nothing. It's showing 6 millivolts. And the power to the house back here, can't really get to it, but 240 again. I got my generator, shut off and disconnected. Now I'm going to kill the power here. I should have nothing coming in from the power company. Yep, 0.5 volt. Nothing from the generator, obviously. There should be nothing going to the house. Yep. Okay. Everything is turned off, shut off. No power, double checked. This has a place for a lock. If you were in a plant or a commercial situation, you would put a lock on this so no one could cut it on while you're working on it. I'm the only one here, so I'm not going to cut the power on myself, so I'm not going to put a lock on it. But That's normally the safety procedure. It's called a lockout tag on or a LOTO. And I should have, I could put a lock on the breaker on the generator. I could put a lock on this. And that's proper work if you're working in a commercial or industrial environment. But like I said, I'm here at my house. I'm by myself, so I'm not going to put a lock on it. So the first thing I'm going to do is I'm going to disconnect these 2-port connectors, take them off, and replace them with 3 ports, and then I'll tie in these number 6s. And since I only got 2 hands, I'm gonna do that and then come back and show you what I did. Okay, you can see I got the neutral one on. Got the 2 4/0 going in and number 6 going in, and it bit down on that good and tight. And the torque specs on these are 360 inch-pounds. My inch-pound torque wrench only goes to 200, so I had to use a foot-pound torque wrench, and that equates out to 30 foot-pounds. You take the 360 divided by 12, and you get 30 foot-pounds. So anyway, I torqued those guys down to 30 foot-pounds. I'm going to cover that up, and then I'm going to do the 2 hot lines. All right, I got all of my 3-port taps back on. Neutral, got the number 6. That one. This one was a bitch. That wire was so short back there, I really had to wrestle it down to get in there. But I got it in, got them all torqued down, measured my voltages, everything is good. My ATS shows that, I've got mains power ready, generators ready. So everything's back to normal. I got the receptacle in there. I checked that where the refrigerator is going to go. It's hot. So now my refrigerator in the garage will stay hot whether I'm on mains power or generator power. So that's exactly what I wanted. So a little bit bigger project than I anticipated, but got it done. So if you like this kind of stuff, please like and subscribe. Thanks.